Thanks for that lovely introduction. Thanks to Michelle Bartlett, as well as Kate Kennedy and Althea St. Martin for organizing the summer sessions talk series, as well as all the other things they got going on. I need to get my kids in one of those camps because I haven't figured all that out yet. Thank you all for coming out. I'm going to talk about beavers moving into the Arctic over the last 20, 30 years. And I'm also going to spend the first half of the talk giving you a little bit of context for the beaver work we've been doing. I've only been studying beavers for about a year and a half, so I'm no expert myself, and there are probably people in the audience, or at least there were in January, who knew quite a bit more about beavers than I do. But I think we've got some interesting findings here, and I hope you'll think so as well. As Kate mentioned, I'm at UAF. But I'm really presenting the beaver work specifically on behalf of a number of collaborators here. Ben Jones, who was formerly with the USGS, is now at UAF as of a couple weeks ago. That's pretty exciting. Chris Arp is a colleague of mine, and then at UAF. And then Ingmar Nietzsche and Guido Grossa are at the Alfred Wegener Institute in Germany. So it's been a group effort, and I'm really presenting particularly the beaver work on behalf of all those guys. But before I talk about beavers, I want to talk a little bit about, like I say, some of the context for the changes that we're seeing up there. And so a little talk outline here. I'll talk first about changes in the landscape in the last maybe 20 to 150 years that are occurring in the Arctic tundra. You know, changes in vegetation, maybe a little bit about permafrost, and then try to see those changes through the lens of wildlife. And so I'll talk a bit about changes in wildlife habitat that we've been able to detect, and how moose and snowshoe hares, which are a shrub-loving species, how we think those have responded, and then it'll be apparent how those are connected to beavers as we get further down. So I got into this whole business doing repeat photography up in Arctic Alaska, and many of you are probably familiar with this work, or at least familiar with the type of changes that are going on up there. You can see this is the tributary of the Nimiuktuk River in the western Brooks Range. You can see 1950 and 2002. Those are shrubs, 2-3 meter tall alder, willow shrubs, maybe some birch mixed in there as well. And you can see the difference between 1950 and 2002, how shrubs have really expanded out on the landscape. Now that's not happening everywhere, but it's happening along a lot of creeks and river floodplains. And we think that that's in response to longer summers, warmer summers. It's kind of like you'd expect, the growing season's longer and warmer, so you get taller, more extensive shrub vegetation in the tundra. And that's something that we initially saw right around 2000 occurring I repeated hundreds of photos across Arctic Alaska and made those observations, but since then people have done similar studies all across the Arctic and seen similar patterns. And of course it's not, like I say, it's not that every square meter of tundra is turning into tall shrub, but this shrub expansion seems to be one of the primary changes in vegetation that is underway in the Arctic, and I think it makes sense with the warming that we have been observing. And of course you see that in satellite imagery as well, right? So on large scales you see that the whole Arctic is getting greener. It's effectively getting more productive as the growing seasons get longer and warmer. Here's a view of the Nimiuktuk River up on the North Slope, 1950 and 2006, and you can see how all these sandbars have filled in. So there's a lot more sandbar exposed in the old photos than in the new photos. And normally, floodplain is not the type of place that you look for responses to warming, because floodplains are naturally dynamic places, much like the boreal forest in some ways. You've got a natural disturbance regime that's going on. But as you look through a lot of these photos, we repeatedly see this sort of infilling of these floodplains with vegetation. And of course, for animals like moose, snowshoe hares, and possibly even beavers, they see that as new habitat. So, one of the questions I had after studying this shrub expansion stuff for a while is, I think we all realize intuitively that wildlife are responding to changes in the environment in real time. We can't necessarily detect all those adaptations that they're making, but I think it's reasonable to expect that if an animal gets more habitat, let's say in the Arctic tundra, more shrub habitat, that we would start seeing, more of those animals, at least in the absence of other factors, and of course there are other factors. So what has been the effect of this enhanced shrub growth on moose, snowshoe hares, and beavers? Moose was kind of an obvious one because if you spend time up there snow machining, dog mushing, flying around in a helicopter, you always see the moose down in the shrubs, particularly in the winter. So as the snow starts to accumulate in the tundra, it buries their forage. They're not adapted to dig through the snow like caribou, for example. And so as the winter wears on, those moose really have to be down in the riparian shrubs. And just to give you sort of a pictorial story of what I mean, you take a picture like this. This is the Nimiuktuk River. We're facing south. That's the continental divide of the Brooks Range, so the North Slope's behind us. It'd be very unusual to see a moose out here right now. There is some exposed forage here because it's a wind-blown area, but it'd be very unusual to see a moose out in this area, particularly in winter. There's just nothing to hide. Moose, and hunters will tell you this as well, moose love cover. They love to be in those shrubs. That's where their forage is, and that's where they can hide out. So this is not moose habitat. And this is what the North Slope looks like. It does have some shrub patches in it, but it's mostly, open tundra, just low stature tundra vegetation. So again, not a place where you're likely to run into a moose. And I can tell you that I've never run into a moose in this type of area in the winter. You see them down in the riparian shrub patches from time to time. Well, now we're getting into an area there you might be able to see a moose. And so I set up some game cameras. This is by Galbraith Lake, the north edge of the Brooks Range. And I set up 28 game cameras one year, taking a picture every 15 minutes. The game cameras stretched from basically Galbraith Lake to the coastal plain. Some were down in the riparian shrub patches, some were out in the open. And they ran for a month, right? So for a month, I pretty much caught anything that walked by. I actually saw over 5,000 caribou observations and over 6,000 ptarmigan observations and all kinds of other random wildlife encounters that you get to see when you're kind of just a fly on the wall. And so here were the only two moose that I saw in 80,000 images, and they actually spent about 6 hours in this frame. This is by Galbraith Lake, as I said. And they spent most of that time, you couldn't even see them. They were just buried in the shrub patch right here, chowing away. And then they spent a few hours lying down resting right here. Meanwhile, caribou were streaming by over here. It was this is a pretty active place, as it turns out. But this is the best view I got of them, incidentally, because they're moving on. So they spent maybe 6 hours in this shrub patch. They eat a whole bunch of shrubs and then they move on. But you could think of this, at least pictorially, as sort of the lower limit of what a moose needs. This is the edge of their range, and they do have patches like this up on the North Slope, but they're pretty few and far between. So barely enough habitat up there to support moose. And so if we go back to the repeat photography, you take a picture like this from 1957, another from 2007. This is Ed Sable. He was up there doing some geologic reconnaissance, and I managed to find it and repeat it some years later. So if we look at the change here from no shrubs in the left-hand photo to some shrub habitat in the right-hand photo, we could kind of imagine that a moose might respond to that type of change. And so it got me thinking, well, if we went back to the end of the Little Ice Age, when a lot of this warming started, 1860, 1880, would it have been cold enough that there was little enough habitat that moose, would there have been enough enough habitat to support moose, 100 to 150 years ago. And so I started digging through historical records, anthropological records, and talking to people in the bush. And I put together this map here showing moose distribution limits. So this is tree line here, this green line right here. You got tundra out here in the Seward Peninsula, the tundra, the Brooks Range, and the North Slope. And what you can see, this is the moose distribution limit in 1880, 1920. And so, what you can see is that 100 years ago, there were no moose in the Arctic tundra of Alaska. And this was kind of somewhat of a surprise to me because I grew up in Fairbanks and there are moose everywhere. We talk about moose as being an iconic species, but it turns out it was not an iconic species 100 years ago. And so we posited that there were no moose in the tundra because they simply didn't have the habitat up there 100 years ago. But as with many stories in ecology, it's a little more complicated than that. There's a pretty interesting theory that was put forth in the 70s that this pattern of moose expansion, which hadn't been portrayed quite in this way, but that this pattern of moose expansion into the tundra was actually the result of a hunting cessation or reduction by indigenous peoples in the early 20th century. And it's pretty interesting. I think it's a pretty compelling idea, actually. So, let's see, where should I start with this one? Well, the thing is, you could give a whole talk on this topic alone. It's pretty complicated to tease these things apart. But yeah, basically, during the idea is that during the 19th century, and possibly earlier than that, indigenous hunters had extirpated moose from tundra regions of Alaska. So they were effective enough hunters, and we know that they were effective hunters, that they had extirpated, they'd killed all the moose in the tundra, and basically when white people showed up and diseases with all the white people and all that stuff, and it really shook up those cultures, and we know that that part is true, and that led to a cessation or a great reduction in hunting by those indigenous cultures, and then the moose were able to essentially reoccupy their former range. So it's hard to pick those two things apart, and maybe it's a combination of both of those. Maybe it's a lessening of the hunting as well as the effects of the increased habitat in the tundra. As time goes on, it's going to be interesting because I've got a snowshoe hare in the lower right corner here, and we think snowshoe hare is making a similar move from the boreal forest into the tundra. Like moose, they have a very similar shrub habitat requirement to moose, actually. But the problem is that we don't have the old observations of snowshoe hares to make a map like this, like we've made for moose. So moose is this big animal. It always appears in old reports from explorers, and every village in northern and northwestern Alaska knows when the first moose was shot in that village. That's actually the way you make this map. But the same cannot be said for snowshoe hares. So there's a lot more uncertainty around hares. We think they're making the same move into the Colville River drainage, for example, but it's really hard to show absence of snowshoe hares in such a vast and remote area 100, 150, 200 years ago. So I think the jury's still out on this. Obviously, habitat is a big deal in encouraging animals like moose and snowshoe hares to move into the tundra. And it's probably already apparent to you how this is related to beavers. But let's move in that direction. So we talked about some of the landscape changes, vegetation changes in the Arctic, how those could be seen at least through the lens of these herbivore browsers. And now we'll talk a little bit about beavers. All right, so I grabbed these verbatim from the ADF&G webpage, and just to remind you a little bit about beavers, these amazing creatures, which I've really it's been delightful to learn more about them and to study them for the last couple of years. Beaver is found throughout most forested portions of the state. Not only the state, beaver's actually the largest uncolonized area of the U.S. by beavers is the North Slope. They've colonized the entire lower 48 except for some deserts in Southern California and maybe Florida. But other than that, beavers have really effectively bounced back from practically being, exterminated due to the fur trade in previous centuries. To survive, beavers must be assured 2 or 3 feet of water year-round. Water provides a refuge from enemies and a way to float and transport heavy objects such as branches and logs for food and construction. Food for winter use must be stored in underwater food caches during autumn. The life of a beaver colony is governed largely by food supply. So you saw the map for moose, about moose expansion, and with moose it's all in hindsight, right? So moose started colonizing the Arctic probably 80 to 100 years ago. But with beaver, it's a little more exciting because I think we caught them in the act. So just to confuse you, here's tree line. Instead of being green, I put it in orange. So tree line's in orange right here. You got the Seward Peninsula, Fairbanks is down here. So the white arrows don't get too excited. The white arrows are predicted, all right? That hasn't happened yet. But basically, historically, beavers are thought to be a forest type of species. They haven't historically been in the tundra regions of Alaska. There may have been a few on the Seward Peninsula, but it's kind of like moose in that regard. They've been a boreal forest species until fairly recently. A couple of years ago, there was a dam observed on the Babbage River. So this is a single dam that they didn't think was there before. And that is, that's the Arctic coastal plain there. But there's also the McKenzie Delta right here. And there have been beavers there for a long time. So might be moving west this way. And then I'm going to focus on this box here where we have been doing some of our research and trying out developing some techniques for detecting beaver movement. So the yellow arrows are the observed colonization. The white arrows are what we think is going to happen over the next, who knows, several decades. So I think the exciting thing about beavers, well, there's lots of exciting things, but one of them is that unlike most wildlife, beavers leave a footprint, they leave a mark on the landscape that you can see from space. And I haven't thought a lot about it, but I don't think there are a lot of animals that do that actually leave such an imprint on the Earth's surface that you can see it from space. But I started thinking about beavers, this was maybe 1.5 years, 2 years ago, and I was excited about the notion, I'd looked at the snowshoe hares, I'd looked at the moose, and I thought, well, what's next to, wander into the Arctic? And I started thinking about beavers, and I had the realization that we could actually monitor beaver movement into the Arctic, or out of the Arctic for that matter, by looking at the formation and disappearance of beaver ponds from space. And so I took that idea to one of my colleagues, Ben Jones, and these guys had already been studying, these are the other guys on this research team looking at beavers, they'd already been studying changes in thermokarst lake, changes in Arctic lake coverage, right? So drainage, lakes forming, lakes draining. They'd already been looking at time series across the entire circumarctic. So of course they knew exactly how to get at this beaver pond question. And you actually use Landsat imagery, which has continuous coverage every single year since 1999. And what the Landsat, it's fairly coarse imagery. That's a 25-meter pixel, so you're not seeing all the ponds, but what it tells you if a pixel's wetting or drying. And then you take that wetting or drying pixel and you zoom in on it, and you get out the high resolution imagery, and then you look at that imagery and you see, oh yeah, okay, a lake formed here. Now why did it form here? Was this a natural process, or, not that beavers are unnatural, but is it a natural process, or did a beaver build a pond here? And so that's how this map is made. And let me just back up for a minute. So just to orient you again, that's the western Nimiuktuk. It's in this box here. So Kotzebue's down here somewhere. The village of Nimiuktuk is up here. This is just kind of the western Brooks Range. And you zoom in on that, and sure enough, there was tons of wetting. So the yellow, whether a box or a circle, the yellow indicates beaver activity. I guess the boxes are the drying. So it was like 4 ponds had dried and 56 ponds had formed. And I'm sure we missed some ponds using this method too. I mean, I think it's over 18,000 square kilometers, so it's a pretty large area. But we were pretty excited to see this result, and it aligns with what people in Nimiuktuk Village and in Shishmaref. I mean, you could talk to the people in Shishmaref, and they'll tell you that beavers showed up in Shishmaref, about 20 years ago. In Nimiuktuk, about the same, and other villages sort of on the tree line tundra boundary as well. So you guys know Jamie Smith. He's the local cartoonist. He's great. But I didn't realize that he was also clairvoyant, apparently, because this cartoon was drawn in 2001, which is, our Landsat time series started in 1999, and I swear this is exactly what it looked like in our study area in 2001. Except maybe there were a whole bunch more beavers, but they were sitting there looking out over this, quote, pristine, let's just say not engineered, tundra landscape with some mountains of the Brooks Range, and thinking, I'm going to take over, damn it all. And that's, pretty much what happened. At least it started to happen. So anyway, I love this particular cartoon because it does, I think this is the situation that we're looking at in northern Alaska, in the North Slope and large parts of the Seward Peninsula as well, is that beavers are moving into these areas where they haven't been for a long time. Just how long we don't know, and I'll return to that a bit at the end. But I think it's pretty exciting. I mean, imagine if someone showed up at the BLM office tomorrow and said, yes, I'd like a permit to put 3 dams on every other stream in northern Alaska. As someone said, that would be a lot of paperwork. But that's what, these are nature's engineers here, and that's what they've begun. So this is what it looks like in the high-resolution satellite imagery. See, 1952 to 1979, not much change. Beaver shows up between 1999 and 2005. You can see it builds a dam right here. There's this little stream flowing into a river. Builds a dam, forms this little wetland, and then by 2013, they've moved the pond down, and it's a little bit more extensive. What that looks like in the Landsat data, just so you can see how powerful it is sometimes. This is a little bit hard to see, but this is the wetness index. So higher is wetter. And this triangle is this triangle right here, right? So the orange triangles refer to this. And what the Landsat, you see, you've got imagery every year. So it starts in 99, 2000, everything is going along, everything's just about fine. And then boom, right here, you can see that dam was built in 2004, right? So that dam was built in 2004. Even though you don't have the high-res satellite imagery to constrain it, you know from the Landsat when that dam was built. And then right around 2005, or 2006, between 2005 and 2006, this drained, and it drained a little bit, and the beaver built the lower dam. And then he rebuilt the upper dam, or she. So the beaver or beavers have, at some point in here, so this is the pond duration down here. This is the duration of those ponds, right? And so at some point they had both ponds going, and then one pond, then they both get blown out or something happens here. And the upper pond gets blown out, and the lower pond gets smaller. But what's interesting about this data is, you can ask some really interesting questions like, well, do a lot of the beavers disperse in the same year? Do the dams all seem to blow out in one year? For, maybe this was because you could look at all the data and you could say, oh yeah, look at that. All the dams across this area blew out that year. A lot of them did because, maybe it was a big snow year, big spring snowmelt. So you can look at dispersal events and all the sorts of things related to timing that I think are pretty interesting. Another example, 1950 to 1985. And this is pretty typical. We've looked at a lot of, Ben, Chris, and I have looked at a lot of time series imagery over the years. And in the Arctic, there's no fire, there's no disturbance like we have in the boreal forest. Stuff looks pretty similar, from year to year, especially from 10,000 feet. I mean, I had to do a double take just to make sure that these were actually different images. I thought maybe Ben had made a mistake, but no, they just look exactly the same. And sure, there are some changes going on. Maybe the shrubs are a little taller, the permafrost is probably a little warmer. But you can see how it's exciting to us, because the minute that beavers show up, it's like all bets are off. Everything changes. You see initial dam development here. It starts flooding this, and immediately when you flood these areas, you trigger permafrost thaw and thermokarst processes. Because water conducts heat better than the pre-existing tundra vegetation. And that's a pretty big deal. That's something that's going to be different in the Arctic than it is in a lot of temperate ecosystems, for example, in the lower 48. So that right there, that's ice wedge thaw, and then by 2012, you've got more sophisticated, you're starting to see a miniature wetland and a lot of thermokarst. And so what they're actually doing is, I talk about beavers sometimes as being agents of disturbance, because they're bringing ecological disturbance to the Arctic. And I think the best analog for beavers, believe it or not, is fire. That's another thing that we've seen a little bit of in the Arctic recently. And those kinds of disturbances aren't really present in the Arctic, or they're not very prevalent except along floodplains. And so it's a pretty big deal, we think, that they're shaking things up in that kind of way. This is actually a oblique photo of that previous time series, just to give you an idea sort of what it looks like. So it's all shrubs. This is on the Seward Peninsula. This dam was formed since 1999. Of course, it used to look like a little tundra stream like this. There's a lodge up here, there's a lodge here, there's dams everywhere. And really has created this wetland. We don't really know what's going to happen, what the implications are of beaver colonization in the Arctic. We have a decent handle on the physical ones, but there have been 0 studies. And so the physical implications we have a better handle on because, thermokarst lakes in the tundra have been studied for over a half century. The biological implications, I think, are a lot more uncertain. So of course you get the inundation of the valley bottoms. We've seen that already. Here's some thermokarst here around this lake. The beaver dams this stream. It actually diverts the channel. It starts making a new channel over here. A whole bunch of thermokarst in here. And you can see it still developing even after the beaver leaves that area. So the inundation of valley bottoms triggers permafrost, changes in hydrology, which is what they do. They're hydrologic engineers. They tend to lead to permafrost thaw. Those are things that we can actually see in the images. The ponding turns out to be a pretty big deal because you have very little unfrozen water in these streams. They tend to be temperature and nutrient limited in the winter, which makes sense, right? I mean, it's the Arctic. There's like a trickle in the bottom of these streams. Well, suddenly you have a pond, and that pond now allows there to be a lot more unfrozen water throughout the winter. That unfrozen water, leaks down out below the dam, so it's not just a localized effect. It's warming up the water where you can possibly have fish spawning and things like that downstream of these dams. So yeah, the ponding makes for warmer water. That's probably the end of what we know with some certainty that's going to happen. Anything thereafter is pretty complicated and And, but maybe increased biological productivity, increased aquatic habitat, or at least more variable aquatic habitat. And I think it might be analogous to dotting the waterways with groundwater springs. You're creating these oases of warm water, these heat sinks, where you're likely to get biologic activity like you would have associated with a spring. More exotic, invertebrate communities and things like that. And here's what we think that ponding and water leaking out down below the dams might look like. Unfortunately, we don't have any quantitative data on this, but so you've got stream A, stream B. Stream B is being diverted by this series of dams here. But if you look in the wintertime image, so here are the dams, and everything's frozen above here, but you look downstream of these dams and you have open water and presumably warmer water. So that's kind of what I'm referring to, and it remains to be seen, whether or not that holds up over, larger areas and larger numbers. But that's kind of what we're predicting in terms of these wintertime oases. This is my impacts to fish slide. And I don't know much about fish to begin with, let alone beaver impacts to fish. So I haven't put anything on this slide. And I think there's a lot of uncertainty. If Randy Brown were here, I might point your questions in his direction. And I'm sure there are people in the room who have a better idea what the impacts to fish will be. It's complicated, in the lower 48 example, there's been tons of research done on beaver impacts to fish. And it tends to be about 2/3 positive and 1/3 negative. But that is a simplification of a really complex topic. It depends on what the setting of the beaver dam is, what kind of ecosystem it is. It depends on what kind of fish you're talking about. I think in a real simple sense, you might be able to say that warmer water leaking out downstream of these beaver dams might have a positive impact in terms of incubating fish eggs. But, as I say, that's the simplification of a complex topic. And, beaver dams block fish passage and tend to create a pretty anoxic environment. So if you have questions about fish, I might refer them to someone else in the audience. But this is certainly this is a really important aspect of it because, salmon, she-fish, things like that are a really big deal in Alaska. All right, just about done here. So as with moose, there's a couple causes of this colonization that we're seeing. Of course, we know that beaver habitat has increased in the Arctic because we know that there's a lot more shrubs out there. There's more discharge in these rivers in winter, which beavers obviously need. And the winter itself is shorter, 2 to 4 weeks earlier. And that goes for moose as well. Beavers are not adapted, their feet are not adapted to walk on snow. So they really have to wait until winter's over, until they come out and, start. They must be hungry. Because they don't hibernate, right? They're hanging out in the lodge with the family for a long, dark winter. And I know that there are some people in here who are sympathetic to that. But then there's, of course, also the recovery from overtrapping in Alaska during the 19th and early 20th centuries. And one of the interesting questions that this brings up is, were beavers prevalent in the tundra prior to the fur trade? And that turns out to be a difficult question to answer. You can look through archaeological records, and that's something that we're beginning to do. But you can imagine you find beaver teeth at a tundra, in a tundra archaeological site, but beaver teeth were traded. So, you really need to find so-called fossil lodges, ancient lodges or dams that have beaver gnawed wood, and then you've got to date all that. And so that's a difficult question to sort out, but I think if beavers were present in the tundra prior to the fur trade a couple hundred years ago, then it's possible that they're just reoccupying their former range. If they weren't present in the tundra, then maybe it makes more sense that it's a habitat issue. and that's what's drawing them into the tundra. So anyway, that's something to consider. I think that's all I got. Thank you so much for coming and for your attention. I've got some time for questions.
Is there an average time that the beavers occupy an area, or just
No.
until the food runs out?
It's a great question. We don't know. But we should be able to answer that in a couple of years. Thank you. Let me repeat the question. Is there an average time that the beavers can stay at a location, or just until the food runs out? And I don't know the answer to that, but that's a great question that we are going to be looking into.
Is the record good enough to tell what the vegetation types were before the onset of the Little Ice Age versus after 1850 or so? Did that have a big effect? Pre-Little Ice Age?
Yeah, so the question is, what do we have any, clear indication of what the vegetation was pre-Little Ice Age? Did I characterize that correctly? What is the vegetation in those areas pre-Little Ice Age? I would say we don't have a refined enough record to see whether or not that might have been a factor. I know they've tried to detect the Little Ice Age in pollen records, and I don't believe they've done so, because pollen is somewhat of a coarse tool in my understanding, but I bet you there are more recent methods that can see the changes in vegetation, can see the Little Ice Age, can resolve the Little Ice Age in a vegetation record, but I don't know what they are offhand. Go ahead.
One of the comments, the Yukon-Kuskokwim Delta is a fascinating place, and beaver exist there far beyond, and in areas where traditional food, like you're looking at here, doesn't exist at all. But the winters are milder, there's a lot of vegetation, tubers will replace shrubs, and it was interesting to see such high densities of beaver in that tundra habitat. But that's not Arctic tundra, that's not even subarctic.
But so a question about the YK Delta and beavers down there, but that is considered tundra. I mean, you're right. It's of a different nature.
It's wetland tundra.
Yeah, right. And so, was there a question?
No, it's just that they existed in a habitat that we don't normally think of, living in interior or the Arctic.
Right. So so beavers existed in the YK Delta, which is a tundra environment.
The Colville River, the lower Colville, I'm fairly familiar with as of about 10 years ago, and it seems that a lot of the shrubbiness that's increased is alder. And alder, I'm not sure of the taxonomy of the alder, but some species are great at anti-herbivore mechanisms, and I wondered if you see any indication that beaver are capitalizing on alder as we would see around here, perhaps.
Well, I'm somewhat embarrassed to admit that I've yet to be out on site at a tundra beaver dam. That's going to change in September. But so I can't answer the question about alder, but you are right that alder seems to be doing well, like in the Colville River Valley. I mean, there's plenty of, I guess what I've seen is there's alder expansion, but there's also tons of willow expansion as well. But, I wouldn't be surprised if that moose showing up in the 40s and heavily browsing the willow may have facilitated a little bit of that alder expansion, because that's what like Knut Kjelland has showed down here in the Tanana floodplain, is that moose browsing actually facilitates the successional shift to alder, which is kind of wild. And beaver could have the same effect. But what I see up north, herbivory is a factor, but the bigger factor is just warming. I mean, I just see a lot of shrub expansion of all different taxa. So.
Is part of the reason why beavers build the ponds to get more shrubs to grow there? Is that their intent, or at least their accidental intent, their Like, so they grow their food essentially by building a pond?
I'm not sure if I can fully answer that. It's a great question. You know, they widen the floodplain. And so the effect is that I think there's a positive feedback in a lot of places where, no, they don't just come in and decimate all the forage and then have to move away. And that's really going to happen in the Arctic because this permafrost disturbance, like shrubs love disturbance, you know. So we don't have the time series yet, and we just simply haven't done the research to answer this question of, you know, what's the long-term effect, like on the shrub vegetation. I think the long-term effect is going to be really positive. They're going to be like boreal oases, you know, warmer water, lots more shrubs because there's going to be permafrost thawing and all this undulating terrain. I mean, when I try to look at sort of the chronology of what happens after a beaver dam comes in, yeah, initially you get a bunch of shrubs knocked down, you get a bunch of shrubs inundated, but I feel like the longer term you know, consequences are a lot more shrub growth. But, you know, that's a guess.
When you fly west from Iliamna, in that tundra habitat, you occasionally see these cattle ponds with ancient beaver lodges that have been covered over with windblown silt and then grass. And it'd be interesting to know how old those lodges are. There's no suitable beaver food within miles of these things. So it just occurred to me you might possibly see something like that on the North Slope.
Yeah, that's a great observation. So you can see these so-called fossil lodges, and you're saying that you think the environment would have had to be a lot more favorable back when those lodges were there. Yeah, that's really interesting. You know, and we've thought a lot about this question because we spent a lot of time on the North Slope, not just myself, but my colleagues. And, you know, you could swear that you've never seen any beaver lodge or, you know, old beaver dam, because, you know, you're always looking for some feature that doesn't quite fit your pattern. Because permafrost does some weird things, but, you know, a fossil beaver dam, I don't, but so yeah, that's a great comment. I mean, I know that there's an old paper from '66 by McCullough and Hopkins, Dave Hopkins, of a quote fossil dam, or I guess it's a dam out by Kotzebue in an area that's now tundra, but of course there's trees in this old deposit, and it's like, you know, I think it's 5,000 years old, a little bit longer time scale, but that maybe alludes a little bit to your comment. That's interesting, though. It'd be cool to get some pictures of that, because that's what we need to look for in these other areas, is what you're describing.
What is the beaver range in Canada into North America? And then, written on that is the French-Canadian fur industry probably has records on that, like indicating prevalence of that.
Yeah. Oh gosh, that was such a good question. How far do they go in Canada? I have no idea. And this other question, but yeah, that's another one that we'll hopefully answer in the next couple of years as we do this satellite image analysis over a larger area. Because yeah, they seem to be, they're right at they've actually gone over the headwaters of the Alatna. They're in the headwaters of the Nigu. So they actually just have to swim downstream at this point. They're in the Conga Cut. The Conga Cut flows north. And they've got that dam that I showed you in northwestern Canada. So they're really, you know, kind of circling the wagons, or I don't know what you call it with beavers, but yeah, in terms of the fur records too, I mean, that's a great point. I just read, let's see, it's Jim Boxtos, I think that's how you say his name. I read his book called Furs and Frontiers in the Far North, which is all about the Russians and the Hudson Bay Company and the fur industry, you know, it starts in the late 18th century and takes you through to the early 20th century. And that was fascinating, but it's really hard because the furs are traded, you know, so it's really hard to figure out where they're coming from. I mean, throughout the book, the beaver is discussed as a forest dwelling animal, but I think it would be more satisfying to get some, hard evidence from the tundra. But yeah, this evidence of absence of evidence is not evidence of absence.
So I have a related question, which is, I don't know much about the whalers, but they used to overwinter in places like Herschel Island, which is just off from the Firth River, which is just east of the Alaska border. And I wondered if maybe there's any kind of records of what they ate, what they were hunting and eating while they were overwintering all along that coast.
So question about what were the hunters, or the whalers eating as they were overwintering or hunting, like at Herschel Island, for example?
Right.
Yeah, I mean, that's a great question. I mean, if they observed beavers at Herschel Island, then, that'd be a great data point. Is that?
Well, and also tree line goes a lot farther north along the Firth.
Yeah, that's true. Tree line goes a lot further north along the Firth than the McKenzie. So maybe there was probably is a greater likelihood of beavers being in that area than sort of far out in distal parts of the tundra. Well, that's part of the fun thing about this project is, now we're talking about history. I'm not a historian, so I've tried to come up to speed on a lot of this stuff, but I'm more just consulting other people who know more about this than I do. One more question?
Yeah, I had kind of a question and a comment. So I've spent a fair amount of time in the eastern Arctic, in the U.S. Arctic Refuge, SAG, that old drainage. There's these groves of cottonwood trees that are very isolated. They're very old. Some people use them for climate science, going back in time. These groves of cottonwood trees have basically, if you fly around in the fall doing a survey, you'll see all the moose in these groves. There'll be 15 moose, 20 moose in a grove. So I started thinking, okay, beavers, they get up there, wow, the only trees up there are cottonwoods. What are they going to do with those cottonwoods?
Right.
They knock them down.
Yeah,
So
that's
then where are these
interesting.
moose? I mean, I'm not a moose biologist,
Sure.
I study fish, but where are those moose? They're using the cottonwood for something.
Sure.
And so my one impression was on western Alaska, which I'm not familiar with, have you noticed their effects on cottonwood groves? And then to follow up on that, and I'll stop talking, is since these trees are very old, and if a beaver was around a long time ago, there might be evidence of beavers and lodges if somebody looked around these groves. I don't know if anybody ever has, but
That'd be the first place to be colonized.
yeah.
Yeah.
Anyway.
Yeah, you make a good point that you could sort of monitor, like there's pretty extensive poplar stands on the Chandler River and on the Colville River, not the Chandelar, but the Chandler, a couple of those. And, I've been watching those pretty careful over the last 50 years, and the fact that they're all standing is an indirect way to indicate that beavers are not in that area, which, I mean, we've floated a lot of those rivers and we do these browse surveys, because moose has a unique browse mark, hares have a unique browse mark. And one thing that we have yet to see is beavers. And I mean, I think a couple years ago we floated from the headwaters of the Niagara to the Colville Delta. So it's like 450 miles of, looking at tips and doing these browse surveys to look at the habitat requirements of moose and snowshoe hares and ptarmigan. But one thing we haven't seen yet is beavers. But you do hear the occasional report that's, that's kind of the fun part of it, So, well, thank you all for coming out and patiently sitting here on such a beautiful evening. So, thank you. I'm going to the Alatna River. Yeah, and the Alatna is, the beavers are up at the top of the Alatna and they're over into the Niagara. So, yeah. Thank you.